Hi guys, so in this specific video we're going to look at the concept of exponents and radicals, and these are going to assist us of course in trying to solve different aspects of exponents and radicals and their various aspects of application. So if I may give an example of a number like 6 raised to power 3, this is going to be a number that has been given in what we refer to as an exponential form. Whereby we see that this is going to be constituting what we refer to as a base, and this is going to be given as a power given as such. So we can be able to give a general form for an exponential form of a number of a raised to the power of n, where n in this specific case is going to constitute of a positive integer, and of course a is going to be a number that is not going to be equivalent to 0 given as such. So therefore we can be able to generalize or give a general form of an exponential form of a number using that specific representation. So apart from the exponential form, we can as well be able to express what we refer to as positive or a negative integral exponents. For instance, I can be able to give an example just like the one I've given above for 6 to the power of 3. This is going to be a positive exponential, rather positive integral exponent, which is going to constitute a positive integral, a positive integer, which is going to show the number of times this particular base has been repeated. So in this case, this implies that 6 has been repeated 3 times, and we can be able to just give this one in this specific representation, or just giving it as such. So therefore, this is the positive integral exponent, which is 3, is going to show the number of times in which the base has been given, and therefore it's going to constitute this specific numerical figure for n, which I've given in this case for 3. So if we can be able to represent this in this specific format, I mentioned about the concept of a negative integral exponent, and for the general representation of a positive integral exponent given as a raised to the power of n, this is going to be a positive. So this is going to be a positive integral exponent. But for a negative integral exponent, this is going to be a raised to the power of negative n. So this is going to be a negative integral exponent generally given in this specific format. So we can be able to represent this negative integral exponent whereby we are going to give this one as a 1 over a raised to the power of n. And as we had said, for these two cases, the letter a, which is a general case, is not going to be equivalent to a 0, and n is going to constitute a positive number or a positive integer, and it's going to be defined in this specific case as a power, and therefore this is going to constitute a positive and a negative integral exponent respectively. So in us trying to refer to as the exponential forms of this specific number 6 to the power of 3, we can be able to read it in different forms by giving it as the third power of 6. So this one can be read as the third power of 6, or 6 cubed, or we can be able to read it as well as 6 raised to the third power in that specific order. So I'm going to look at an aspect, of course, of these specific exponents, and that is going to assist me in trying to introduce this concept of radicals that I've mentioned in my second part of this specific discussion. So therefore, we're going to use the radical, or rather the exponential form, in order to define what we refer to as that specific radical that I've mentioned. So I've got an expression of the form, or an equation of the form a raised to the power of n is going to be equivalent to a particular value. Now in this case, we have seen that a is going to be raised, the base is going to be raised to a number of times, which is of course a positive integral exponent, in order to find the number of b. So we say that this is going to be a base, and this is going to be a positive integral exponent given as such. So we can be able to define another term before we look at the radicals referred to as the roots, and these are going to be particular numbers which are going to be positive integers, and we can be able to define these specific roots, whereby we're going to see that if we have a number, a specific number, 2 raised to the power of 3, this is going to be equivalent to 8. So therefore, if we're going to find the third root of 8, and then this is going to be given as 2. So I'm just going to give this general representation, but I want us to have a general definition for this specific case for a root. So if we have a number a and b, which are going to satisfy this equation of a raised to power n is equivalent to b, then we're going to have a number n which is going to be an integer. Then we can be able to define a as an nth root. So a implies an nth root of this specific product b, which is going to be given as such. So in form of an expression, we can be able to define a root of whereby this particular base is going to represent an nth root of this specific number b, so long as this one satisfies this specific condition that I've given in that particular case. So therefore, we are going to look at various forms of roots, and if we try to look at this specific case that I've given, then therefore we are going to see that if nth is a root of a particular number b, this is going to be referred to as a principal nth root of that specific number. So in any case, if we come across this specific term for a principal nth root, then therefore it can be presented as this specific form of a that I've given above. So therefore we can be able to give this one in terms of an expression whereby we're going to have the nth root of b representing the principal nth root of a number b given in terms of an expression as such. So this is an expression representation of this specific statement. So therefore, from this specific expression, we can be able to define various terms which are going to be used in this particular case, whereby we are saying that this is going to be the nth root of this specific number b, and therefore it's going to be called another name which we refer to as a radicand. So therefore this is going to constitute, or rather it's going to be referred to as, sorry for that, it's going to be referred to as a radical expression, and therefore we are going to see that this specific number, which is of course the product of this number, is going to be referred to as a radical. It's going to be referred to as a radicand. So I'm just going to give a clear expression for this. So this is going to be b, and this is going to be referred to as a principal nth root of b, as I've said. Now this specific number that I've given in this particular case, which is going to be the number of b, is going to be referred to as a radicand. And this general expression is going to be referred to as a radical. And of course, we're going to see later that this specific number n, which has been used in this particular case, is going to be referred to as the index. So therefore, these are going to constitute various forms of various parts of this specific radical which I've mentioned. And lastly, we're going to see that we can be able to express these specific exponents in terms of fractions. For instance, if we have general numbers for m and n, which are positive integers, we can be able to express a in terms of an exponential form of m all over n. And this is going to represent a number of a raised to power n, and this so this is going to constitute our principal nth root, or rather our principal nth root of. So we have said, so to avoid confusion, I'm just going to give it in this specific context. We have said that this is going to constitute an index. In this particular case, for the 1 over n is going to constitute our index, and therefore we're going to see that. Of course, this specific aspect of the radicand is going to be a to the power of n given as such, and we can be able to give it in terms of a fraction given using this specific conversion. Of course, we have talked about the laws of indices and logarithms, and I'm going to put a link in the description box so that it can be able to give more elaboration on the last bits that I've talked about. So I presume that we have understood various aspects of the basic aspects of exponents and radicals. So in any case, if we come across them and we are talking about the concept of a radical or a radicand or a principal nth root, then it's going to be elaborate for us. So catch us in our next video, and kindly check in our description boxes for various links of other related videos which are going to assist us comprehend on the same aspect of exponentials or exponents and radicals. So that is it for now, guys. Bye, God bless.